Okay, ladies and gentlemen, let's look at another little video on solving systems of equations using the elimination method, and this will be video number 2. Alrighty, so example 1, I have the 5x minus y is equal to 16, 3y plus 2x is equal to 3. The first thing I'm going to do is label these particular equations, and oh heavens, the first thing I want to do is I want to line up the x's and y's. So I like the x's to be in the first spot, so I'm just going to rewrite the first equation. Minus y is equal to 16. And now I'm going to rewrite L2. So I'm going to rewrite, and I'm actually state what I'm going to do over here. I'm going to rewrite L2 so that the x's and y's line up. So the 2x goes here. All right. Rewrite them in red. The 2x goes here, minus 3y, or plus 3y, sorry, this is a y, is equal to 3. And now I notice I want to have a magic number. I want to be able to add those equations together so that one of the variables is eliminated. And it looks like if I multiply L1 by 3, that would make it so that the y's could be eliminated. So let me make sure over here, first and foremost, that I am on zoomed out as much as possible. So that's exactly what I'm going to do. I'm going to multiply L1 times 3, and that's going to give me a new equation here. Let's multiply this in by 3 here. And what does that give me? That's going to give me 15x, 3 times 5, 3 times negative y minus 3y. 3 times 16 is 48. And I'm simply going to rewrite L2, which is 2x. I want to make sure that I keep my equations this time. I want my problem to be nicely formatted. So I'm just going to rewrite my y's, my L2. And now I'm going to add the two equations together. And I see that when I do indeed add them together, the y's are going to be eliminated. So that's the first thing I'm going to do is add the equations together. And it looks like I have, if I do add them together, I have 17x, the y is a 0 out, 51. And now I'm going to solve for x. And it's easy. If I divide both sides by 17, x is going to equal 3. 15 divided by 17. Now what am I going to do? I'm going to put x equals 3 in the original L1 and solve for y. Okay, so the original L1, this was the original L1 right here, is 5x minus y is equal to 16. I'm going to put 3 in for x. So this is going to be 5 times 3 minus y is 16. That says 15 minus y is equal to 16. And 15 minus what is 16? That says y is going to be negative 1. So my solution then to this, the solution to this equation is going to be 3, negative 1. And we know what we need to do next. What we need to do next is to check my solution. So I'm going to come up here. My solution is 3, negative 1. I'm going to write that up here, 3, negative 1, and this is going to be my check. I'm going to get this guy out of the way. And this is going to be my check. And I'm going to put 3 into L1, this point. So it's going to be 5 times 3 minus negative 1. Does that equal 16? 15 plus 1, check OK. Put it in L2. Does 3 times negative 1 make sure that the original L2 had the 3y first. And so 3 times negative 1 plus 2 times 3, does that equal 3? Well, this is going to be negative 3 plus 6, does indeed equal 3. Check OK. So this is indeed my solution. All right, give you a moment to write that down. We'll zoom out here. Let's get this guy out of the way. And look at the entire page. And you can look at the entire page. Okay, so let's look at example 2 here. All right, the first thing we're going to do is we're going to line up the x's and y's, and I do not have the x's and y's. First thing I'm going to do, this is label L1, this is L2, and I'm going to rewrite L1 because I have it in the way I want it. I want the x's first, plus 40y is equal to 55. I'm going to rewrite L2 to line them up. The 7x goes here, and then this is going to be minus 8y is equal to negative 11. And so now I want to find a magic number that I can multiply one of the equations to, so that when I add them up, a variable is eliminated. And what I'm going to do is think about this dude right here, 7x, and I'm going to multiply this equation here. I'm an L2 by negative 5. So let's rewrite L1 here. It's going to be negative 35x. Sorry, I want to keep everything formatted nicely. Negative 35x plus 40y is equal to 55. And I'm going to now multiply L2 by negative 5 and see what I get. Negative 5 times 7 is negative 35x. This is going to be nice. Negative 5 times 8 is 40y. Oh, negative 5 times negative 11 is 55. And I see that when I do indeed add the equations together, I get 0 does equal 0. And what does that mean? That means that the solution, this is a true statement. This is true. What does that mean is that there's infinitely many solutions. Infinitely many solutions. And the system then is consistent. There is a solution. Consistent and dependent. Excellent. I'll pause the video here and let you copy that down. Make sure you're on. All righty. So let's go to the next example. One thing I want to do, oh my goodness gracious, this is a dandy, Randy. All righty, so the first thing we're going to do here, first of all, we're always going to name our equations. And what we need to realize is that fractions are not fun. Fractions are not fun, so I'm going to multiply both of these equations by a number to clear the fractions. So if I notice, what am I going to multiply L1 by to clear those fractions? If I multiply So what I need to do, I accidentally paused the video. So what I need to do is first and foremost is clear the fractions. So I want to get rid of those fractions. And I see I have all these denominators of 5 and 6. 30 is going to be a least common multiple of those denominators. So the first thing I'm going to do is I'm going to take 30 and I'm going to multiply L1 times 30. And I'm going to multiply L2 times 30 to clear those darn fractions. So let's do this guy first. And keep in mind, 30 is the same as 5 times 6. 5 times 6, not 5 times 5, silly head. And let's do this funky purple color here. I'm going to multiply by 30. 30 is 5 times 6. And let's go first and foremost, 30 times 3/5 x. If I go here, the 5's cancel, and I have 3 times 6, which is 18x. 30 times 1/6, the 6's cancel, is negative 5y, is equal to 30. That's L1 rewritten, L1 multiplied by 30. Let's do L2 multiplied by 30. And 30 times 1/5 is going to be 6x. Sorry. And 30 times 5, the 6's cancel, is negative 25y. And 30 times 11 is 330. It's a big number. So the next thing I want to do is multiply some equation by a number so that when I add them, I can eliminate one of the variables. And what I'm going to do is there are multiple ways and multiple correct methods, or multiple, not correct methods, there are multiple correct numbers to multiply these equations by. And I'm going to look at this negative 5y, and I'm going to make him 25y. By what am I going to do? I'm going to multiply this dude right here by negative 5. Negative 5 times negative 5 is 25y's, and therefore I can eliminate the y's. So I'm going to write this down. I'm going to multiply L1 by negative 5 and see what I get here. So I have negative 5 times 18, and that is going to be 90, negative 90. X, 5 times 5 is probably positive 25y, I'm sorry. And 5 times 30 is negative 150. What's going on here? And I'm going to rewrite L2 here. And L2 is going to be 6x minus 25y is equal to 330. Oh, big numbers. Well, you have a calculator. If you would like to use a calculator, it's no problem about that. Now I'm going to add these equations together and see what I get. I have negative 84, adding them together. I have negative 84x. The y zero out, and I have 330 minus 150 is 180. Okay, to continue with this here. Yes, I see a little bit of an error here. Hopefully you have seen that. When I multiply L2 by 30, 30 times 1/5 is 6x. 30 times 5, 6 isn't negative 25y, folks. That's positive 25. So that caused a lot of error. And so I don't want to multiply L1 by negative 5. I want to multiply L1 by positive 5. And so that's going to change a lot of things here, and it's going to change some numbers. So I want to multiply that by positive 5. So 5 times 18 then is going to be positive 90. 5 times negative 5 is going to be negative 25. 5 times 130 is positive 150. So we're going to need to clean your notes up here a little bit. Good thing I caught that rascal. And now when I add them together, and keep in mind, if I rewrite L2, this dude here is going to be positive. This is all positive. And now this changes this equation here. Now when I add them together, I get 90x plus 6x is going to be 96x. 150 plus 330 is 480. And now when I divide by 96, I get x is equal to 5. And we knew that's what we should do at this point. We should solve for x. And now what we do, we're going to take and we're going to put x into L1. We're going to put x equals 5 in L1 and solve for y. So let's do that. Let's see L1. Oh, that's nice. L1 is going to be 3/5 x. So we're going to go 3/5 x, which is 3/5 5, plus I'm going to have to scroll up here to see what the original L1 minus 1/6 y, minus 1/6 y, and that was equal to 1. And this is going to work out real nice. The 5s will cancel. I have 3 plus negative 1/6 y is equal to 1. Subtract 3 from both sides, and I get negative 1/6 y is equal to negative 2. Multiply both sides by 6, negative, and I get y is equal to 12. So my solution then, is 5, 12. Big numbers, not really. Nothing we cannot deal with. I think we can. And so what we're going to do now, we're going to check our solution. So let's jump up here, 5, 12. And we're going to get this rascal out of the way here. And we're going to check 5, 12. And we're going to put it into the original equation. So we're going to go 3/5 times 5 minus 1/6 times 12. Does that equal 1? Well, this is going to be 3. 1/6 times 12 is 2. Minus 2 does indeed equal 1. Awesome. We're going to put it into the next equation here. 1/5 times 5 plus 5/6 times 12. Does that equal 11? Well, 1/5 times 5 is 1. 5/6 times 12. 12 is 2 times 6. The 6 is canceled. 5 times 2 is 10. Does 1 plus 10 equal 11? Check OK. So we are good and golden with our solution. I have one more example that I would like for you to do. And this is that example. I would like to give you a whirl. Give this guy a whirl. I'm going to pause the video while you... Okay, the final example here is going to be this 2x plus 5y is equal to 4, 3x plus 6y is equal to 5. This time, this is an interesting problem since it's not going to be any single number. So what I've chose to do is multiply L1 by negative 3. By negative 3, and I chose to multiply L2 by 2. And then when I do that, these are the results. 3 times 2 is negative times positive is negative. Negative times positive is negative. Negative. 2 times 3 is 6. 2 times 6 is 2 times 6 is 12. 2 times 5 is 10. Now I can add them together. I think this is the first example where I had to multiply both equations by a number. Add them together. I get 3y is negative 3y is negative 2. Y is 2/3. Ooh. So when I think this is the first time we came up with a daggone fraction. So now we solve for y. Y is 2/3. Put y equals 2/3 into L1. I put that in there right now, and I'm going to multiply both sides by 3. Multiply both sides by 3 to get rid of that fraction. I get 6x plus 10 is 12, and that says x is equal to 1/3. Now I'm going to check my solution. So my solution is 1/3, 2/3. And I'm going to check my solution. Here's the solution check right here. The solution checks. 2 times 1/3 is 2/3. 5 times 2/3 is 10/3. 12/3 does indeed equal 4. And L1, 3 times 3/3 plus 6 times 2/3 is 4. 1 plus 4 is 5. And so what I'm going to do here is I'm going to zoom out to the entire page. And now you can take a picture of that because we're approaching 20 minutes and I'm going to end the video. And so this is solving systems via the elimination method, video number 2. So I will catch you on the flip side, either in a Google. Both of these videos are going to be required watching. So happy watching, take care, and be safe.